So in this video, we're going to talk about what descriptive statistics are and why we care about them in the first place. So we're going to start with sort of a motivating question. And that question is, are you tall? Or how tall are you? For just you, that's a pretty easy question to answer, right? You might know how tall you are based on your last doctor's appointment or the last time you measured yourself. So it's pretty easy to answer that question for yourself as an individual. But what if I asked, and let's say you're 68.76 inches tall, right? The question is answered. But what if I asked, are you and your roommate tall? And one of you're 68.76 inches and your roommate is 70.72 inches. And I just said, how tall are you and your roommate, or are you tall? Are you the two of you tall? That answer might be a little more complicated, right? Because all of a sudden you're answering this question for two different people, but I only want one answer. Or we can expand that question to include an even bigger group. Is your FYS section tall, right? And this is your section and all of your corresponding heights. If you just looked at this, how would you answer that question? Right? So let's expand it even more. And what if I asked, is the first year class at Cornell tall? And I gave you this, which is all of your heights in inches. It's not your real heights. I just made up this data. But how would you answer that question based on this, right? So these are data, and we need to find a way to describe and summarize these data, right? Because what I gave you with just that table of numbers is not helpful at all in trying to answer that question. So we need some way to describe and summarize all of that information. And so that's why we have descriptive statistics. So we're going to start with one you've probably heard about before, which is the mean or the average. So to calculate the mean or the average of the heights of all of these first years, this is probably a review, but you add them up, which if you add all of these, it's 21,554.64 inches, and you divide by the total number, which here is 320. And you get that the average height of first years at Cornell, in this made-up data, is 67.36 inches, right? So this is the mean or the average, right? So this is one way that you could describe this data. Another way you're probably familiar with is the median, where you line up all of the numbers from smallest to largest, and you find the middle values, which here, since we had an even number, is actually two numbers. So when it's two numbers, you take the average of those. If they're an odd number of people in this data set, you would just take the exact middle value. And so if you take the average of those two numbers, you get 66.89 inches, right? And this is called the median or the middle value. So this is another way you can describe and summarize this data on all of the heights of first years. So if we want to visualize that, this is a histogram of all of those heights. So along the x-axis on the bottom, we have the number of inches for each person, and on the y-axis, we have a count. So each of these bars shows how many people are a particular height. All right, so the height of the bar is the number of people who are that many inches tall, right? So to sort of visually see what the mean and the median look like, here this red dotted line is the mean. So this is the numerical average of those numbers. And the median is represented by this blue dashed line, which is the middle value when all of the values are arranged from smallest to largest, right? So these are, as you can sort of tell from that visual, we call them sort of a few different names, measures of central tendency. They're also sometimes called measures of center, measures of location. So the mean and median are two examples of measures of central tendency, measures of center. And the goal of these measures is to give a typical value. It's a way to summarize all of that information on heights, right? It's not useful to see a table of 320 different numbers. But getting something like the average height or the median height is a lot more useful and a lot easier to sort of interpret and digest. So one type of descriptive statistic is these measures of center, and the mean and median are two examples. So as you notice, though, those aren't the exact same. So I want to talk very briefly about the relationship between them. So this is that same graph I showed earlier, except now I've extended the x-axis to include much higher numbers. So let's say, right here you can see the mean and median are not that far apart from each other. But let's say that Cornell had a special outreach program that we were going to admit a bunch of giants to the freshman class. So we admit like something like 45 giants. And all of a sudden, we have a few students who are very, very tall compared to the rest. So you'll see here now that our average, represented by the red dotted line, has pulled quite a bit over to those higher values, while the median hasn't changed that much. So one important thing to note about measures of central tendency, especially the mean and the median, is that when you have really skewed data, so you have a lot of values sort of scrunched together on one side, and then a lot of really big or really small, a group of very, very small or very, very large observations compared to the rest of your data, it can pull the mean and median apart. And so one of those measures alone might not actually describe the data as well. So that's something to note about those how those two different measures can be different from each other. So basically, though, that suggests that measures of central tendency can leave out really important information about your data. So there's other descriptive statistics that are really important to calculate and know for a data set. So let's sort of do a fun example. Are these 5 roommates, which the 3 in the middle are gymnasts and the 2 on the edges are basketball players, are these roommates who happen to live together, are they tall, right? That's sort of a tricky question to answer, right? You'd be like, I mean, some of them are tall and some of them are not tall. But then if I asked you about these 4 roommates, it's a lot easier to answer that question, right? If you like knew their heights, because they're all sort of similar heights. It's much easier to answer the question because you don't have these huge discrepancies in height. So this challenge is why we have this other measure that we're interested in. So let's take these roommates that are basketball players and gymnasts and sort of expand that out and say we have data on all of the gymnasts and basketball players in a freshman class. And that looks like this. So we have a group of freshmen who are very tall and a group that are not very tall. So when we find the mean and the median, right, they're still sort of like in the middle here. They don't represent any actual heights of gymnasts or basketball players. But then if we had data on sort of a non-gymnast and non-basketball player freshman class, right, it might look something like this. So this is more representative of that group of roommates that are all the same height or around the same height. So the important thing here, right, is between those two pictures, the average or the median heights were probably more or less the same, right? And these two graphs show, these two histograms show that you can have 2 different sets of data that look very, very different. But if I only told you the mean and the median, you wouldn't know that they were different at all. And so that's why we have a really helpful measure called standard deviation. So the standard deviation for the gymnasts and basketball players is almost 6.5 inches. The standard deviation for a group of non-gymnasts and basketball players is only 2.56 inches, right? So in this graph that's sort of made up of that sort of represents those roommates that are all sort of similar heights, right? We have a lower standard deviation compared to that picture of gymnasts and basketball players. And so what I'm trying to sort of get at is this intuitive reaction that you might have had when you saw the gymnasts and basketball players and I asked you, are they tall? It's a hard question to answer. And it's hard because the standard deviation of their heights is really big. But it's easier to answer that question when the standard deviation in the other picture was quite low because they're all similar heights. So the standard deviation is a measure of how similar your data points are to each other. And so what it's actually doing is saying, are your data points sort of on average far away from those measures of center, or are they close to the measures of center and sort of tightly clustered around them? So these are, standard deviation is what's called a measure of spread. You might also hear it referred to as a measure of dispersion. So the standard deviation is sort of the central one and the only one we're going to talk about during your FIS. And the goal of this measure is to tell you how spread out your data are from that average value or one of any of the measures of center. So to calculate the standard deviation, you subtract each data point from the average and square that value. You take the average of those squared differences, and then you take the square root of the average. That seems sort of complicated, but we're going to walk through an example. But basically what you're doing is for each observation, you're saying, how far away is it from the average? And then you're taking the average of those distances. It's a little complicated because of the squaring, and there's reasons for that we're not going to get into, reasons why you do that we're not going to get into in FIS. But let's walk through an example with heights to hopefully make that a little clearer. So if you have this set of heights, here we have 59 inches up to 73.39 inches. The first thing we want to do is find the average of those heights. So the average is 66.74833. So the next step is for each of those heights to subtract it from the mean. All right, so what we want to know is how far is each data point from the average. Right, so we get this set of numbers. Then the next step is to square those differences. So we have height minus the mean squared. And then we're going to take the average of all of those squared differences, which is 15.552. And then the final step is to take the square root of that average, which is about 3.94. So the standard deviation for this set of heights is 3.94 inches. Right? So that tells us how spread out our data are. So knowing this by itself is not always super helpful, but it's helpful when you're comparing two different data sets. You could say one data set has observations that are much more spread out compared to another one, just like we did with the data set of basketball players and gymnasts. The standard deviation was much higher. That data is much more spread out compared to the data of sort of those girls who are all the same height. So to sort of review all of these descriptive statistics, they are measures of center and measures of spread, and they're used to describe and summarize data, right? Because when we have this big table full of numbers, or it's a list of numbers, it's really hard to sort of parse that and figure out what we're supposed to get from it. So descriptive statistics are letting us do that. So we have two different types, measures of center or central tendency and measures of spread. Measures of center are going to tell you where the data are located, sort of what the typical value is. So that includes mean, which is the numerical average, and median, which is the center value. And then measures of spread are helpful to tell us how spread out the data are from the center. And the measure of spread we're interested in this class is going to be this standard deviation, right? Which, this is sort of a mouthful, is the square root of the average squared distance from the mean, right? Normally this isn't something you calculate by hand for a big data set, but it's sort of the interpretation that's important here. So it tells you how spread out data are. So in a follow-up video, we're going to talk about how we can use descriptive statistics and start doing inferential statistics, which is where we take these descriptive statistics about a sample and we try to talk about a population.